Hello everyone, and welcome to this session on Zero Code AI with drag and drop machine learning. My name is Tegan Riffat, and I am fortunate enough to be working at Microsoft as a partner technology strategist. Now, like many of you who I suspect that are watching this, I do not proclaim to myself to be a quote-unquote data scientist by any stretch of the imagination. And so when I see technologies like the ones that we're about to kind of go through that really enable us to take advantage of these modern AI capabilities to derive those deeper, more meaningful insights, it's something that I personally get really excited about. That said, we are going to be covering a number of services, personas, and workflows. So if you are a data scientist in the true sense and prefer to cut your teeth into some code in a notebook, stay tuned because I do think that there'll be something for everyone in this particular session. Now, when I started compiling this, one of the things that it forced me to think about is, what role outside of the traditional data scientist is the Azure Machine Learning service geared for, specifically AML designer. And so I thought it'd be interesting to do an experiment. Well, I had some preconceived ideas. My background pre-Microsoft is within the business intelligence space for like over 10 years. I've got friends, family, and colleagues who specialize in data and AI. And so I had my perception, but I thought it'd be interesting to collate all the open job listings that match the term data scientist. And this is within a particular point in time for the London, UK job market. And that resulted in about 150 listings. And so we grabbed all the job descriptions, and this word cloud that you can see here is the visualization off the back of that. And so the words that appear larger, it's based on the percentage of the job listings that those phrases appeared. And the color is a loose, post categorization of those phrases. And so you can see, for instance, the green words are, programming languages and libraries that maybe the data scientist has, and that's what the kind of recruiters in the job market is looking for. And so this led me to certain insights to arrive off the back of that data. Python is definitely king. If you rewind like 5-10 years ago, that wasn't always the case, right? You had R as the definite preferred language of choice before Python came in the scene within the data science community. Now, every year since then, Python has been growing, exponentially in popularity, and you can see here that gap is now wider than ever, with the vast majority, a whopping 82% of listings looking for someone with Python skills, and more specifically, experience with particular libraries like NumPy and Pandas and PyTorch. Second to that, so we've got a decent number, 38% of these listings looking for data scientists with experience in one of the hyperscale cloud vendor platforms. And so for Microsoft, that would be Microsoft Azure. And then finally, again, recruiters and organizations looking for data scientists that have a formal qualification of some kind. And so I think the vast majority were like PhDs, but that also included masters and bachelors of science. And so this really helped me build an image, an illustration of what, in my mind at least, of what that ideal candidate looks like. And you can see here we have an expectation with a background in analytics and statistics, formal degrees, familiarity with Python, but specific data science libraries. And if you overlay all of this with the business domain knowledge required, right, which is just not, if not more important than the technical capabilities on the individual, then it leads me to the conclusion of what we're really looking for is one of these. And that's great, for the handful, maybe, of people within your organization that may resemble anything close to that. But what about everyone else? And that really brings us to the intent of what Microsoft is trying to achieve. So while we definitely do have platforms and services to empower your existing data science teams to be as productive as ever, with support for popular frameworks such as PyTorch and TensorFlow and scikit-learn. Simultaneously, we are investing in other areas such as cognitive services, which you can see at the top, to empower individuals of all skill levels in order to take advantage of innovations in AI. And so cognitive services, these are pre-trained models that Microsoft have built, and developers can simply grab the API off the shelf and start to do things like object detection, OCR, speech to text, natural language processing, key phrase extraction, the list just goes on. So with that in mind, I'd like to drill into 3 authoring experiences we have sitting on top of the Azure Machine Learning service that enables us to build, train, and deploy machine learning models faster. So starting on one end of the spectrum, we have automated ML. This is great for business domain experts who know a lot about their data, but they don't necessarily know much about machine learning algorithms or code for that matter. And so the automated ML interface allows customers to automatically generate models for their data in a no-code user experience. It's literally 3 steps. Step 1, select your data. Step 2, tell automated ML which column is it that you would like to predict. And the final step is what type of machine learning task is this? Is this classification, is it regression, or time series forecasting? They're the categories that we currently support. And so automated ML will kind of take all those inputs and basically brute force the best model for you. It will do a whole bunch of feature engineering if you choose to let it. And even whether it's the ML novice who doesn't know how to play with ML algorithms or code, or the ML expert who simply wants to rapidly prototype and get to a kind of baseline quicker before they start doing things in a code-first environment like notebooks. And so notebooks, on the other end of the spectrum, we have native support for Jupyter Notebooks directly within the Azure Machine Learning service. This is great for developers and data scientists who prefer to code, prefer to have full control, would like to use the libraries and the frameworks and the tools that they're used to. And so in addition to native support directly within ML Studio, we also have, and you can see in the snippet here, support for authoring notebooks in Jupyter or Jupyter Lab as well. So if you're used to those environments, you've got that flexibility. And then finally, the drag and drop machine learning experience with Azure Machine Learning Designer. And so this is great for people that are learning machine learning concepts and want to build models themselves, but don't necessarily have a proficiency in Python coding skills, for instance. Now, conceptually, where these tools sit, if we have like a horizontal axis of no code to code first, and a vertical axis of no ML to ML expert with automated ML and notebooks on either end, AML Designer straddles a nice balance between those two. Now, while you may be thinking, AML Designer, it's a visual environment, it should be sitting all the way on the left in no-code land. The reason why I've got it in the middle there is because while it is a visual first experience, it's not visual only. And so we have the option, as and when needed, to interject things like Python and R code if that's what you feel is appropriate. Now, the great thing about these 3 authoring experiences is that they're fully integrated to the broader Azure Machine Learning ecosystem. And so we get the benefits of the unified management experience, the ability to do versioning and tracking of datasets, modules, and pipelines. And so we kind of get all those benefits as part of the one stack. With that said, I want to now switch over to demo this functionality. Okay, so here we are in the Azure portal, and while so the aim of what we're going to be trying to do is to build a machine learning model to predict the selling price of a car. Now, as we're trying to predict the numeric value, the statistical approach that we'll be using is referred to as regression, and this is an example of supervised machine learning because we have our training data will be based on a complete set. It will be the features as well as the known values. And so the features in this instance are the characteristics of the car, number of seats, horsepower, make, model, size, all that kind of stuff. As in the known values, the labels, that will be the selling price. So we'll have a historical data set where we've got like Subaru, it's of fuel type gas, and it costs $9,500. Now, before you can get started, you will need an Azure subscription as a prerequisite. And so if you don't have one of these, you can create an Azure free account. Now, depending on your locale, so in Australia, it might be $280 worth of Australian dollar credit. In the US, I think it's $200 US, and so it will vary based on your local currency. But once you do have your Azure subscription, we can come on over to the Azure portal, and we're going to create an Azure Machine Learning workspace. Now, I've already pre-created mine, but for sake of completeness, let's show you what that looks like. Okay. So you can see here I've got the usual suspects in terms of what we need when we're creating a resource of this type. Subscription resource group, my unique name, a region. The thing to note is when you get to Workspace Edition, you will need to select Enterprise. This is the only SKU that incorporates the UI experience in ML Studio, as well as the drag and drop authoring piece with AML Designer. In addition to that, you may notice you've got this note in the blue box, and all that is saying is that as part of the AML workspace resource creation, we are also going to be spinning up an Azure Storage account, Azure App Insights to do monitoring, and Azure Key Vault in order to store sensitive credentials in a secure manner. And so let's go back to the dashboard. We already have a machine learning workspace ready to go. And I'm going to launch into the new Azure Machine Learning Studio experience. Okay, so you can see here I've got my sidebar. In terms of the main screen, so at the bottom we have recent resources, some compute, which we'll get into in a second, tutorials and links, and at the very top we can create brand new machine learning assets. Now, before we can start building our pipeline, the first thing that we're going to need is some form of compute. And so if I head on over to the compute section, you can see we actually have 4 different kinds of compute in Azure Machine Learning. Compute instances, these are pre-configured workstations for data scientists, right? They come pre-installed with all the tools and the libraries that we're used to. So they'll have Python installed with all the libraries readily available, the ability to launch Jupyter or RStudio, for instance, from a compute instance. And these are typically used when we've got a notebook and we want to attach that notebook to a compute resource in order to execute the code within the cells. Compute clusters are used when we need to train a model. So if we've got a pipeline or experiment and we want to run some code within that experiment, we're going to need something more beefier than a compute instance, and that's where the compute clusters come in. And so if I click on New, you can see here we've got the option to create CPU or GPU variant compute clusters. So if I select GPU, all that's going to do is change the virtual machine size option list to include a number of those that have these NVIDIA Tesla graphics cards attached. And that might be appropriate for the specific machine learning task that you're trying to tackle. Now, if I go back to CPU, you can see I've got a whole variety of options from general purpose, memory, and storage optimized, with a number of different configurations across cores, RAM, and disk. And so depending again on the machine learning task, you may want a specific type of cluster with a certain number of nodes spun up. Now, speaking of nodes, if you've used Azure Data before, this concept of auto-scaling hopefully is not new. So we can set a minimum and maximum number of nodes that we want our cluster to scale up and down to, depending on the amount of activity that is happening. And so when things are really volatile and spiky and we've got a lot of usage, we'll have that scale up. When things are idle and going back down again, we want that cluster to resize in order to save some cost. Inference Classes, this is a third type of cluster, and this is backed by the Azure Kubernetes service. And so we need an inference cluster when we want to deploy a predictive model to a RESTful endpoint. And so that is quite useful when you want to hand over your model to a developer that can simply consume it as an endpoint API, right? And so that's backed by Azure Kubernetes, and you can see we have an AKS cluster there. And finally, this ability to attach compute. So if you've got an existing Azure Databricks cluster or an existing HD Insight cluster, you can attach or set up a link basically from Azure Machine Learning to those existing resources that you have within your Azure estate, rather than having to create things net new. Okay, so we have our compute. Next is how do we get our data in? And there's 2 key concepts that we need to understand when it comes to data. There's data sets and data stores. So data stores are quite simple, and you can think of those as an abstraction of the connection string. Now, if you've used Azure Data Factory before, this is very similar to the concept of a linked service. And so if I want to create a new data store, you can see here I have a number of options from blob storage, Azure Data Lake storage, SQL environments, and more. And depending on which one I pick, so if I pick Azure Blob Storage, I'm going to get presented with a set of options. In this case, it's asking me for the account key. If I switch over to a SQL resource, for instance, I'm going to get a different set of prompts. In this case, it's the SQL username and password. And why do we want this? We don't want to keep entering these sensitive credentials every single time. We want to authenticate with a data store in order to retrieve the data set that we're after for our machine learning workflow. We just want to reference it by name. And so we set this up once. It gets stored securely in Azure Key Vault behind the scenes. Now, if we've got our data store set up, we still haven't got our actual tangible data resource. In this case, the Azure Machine Learning Dataset. Now, there are a number of ways to pull through references to Azure Machine Learning datasets. One is local files, and I will walk through that as an example as part of this demo. The next is from an existing Azure data store. So if you've got a dataset sitting in a data store, we can pull it through that way. If you've got datasets sitting behind a web file, so it might be www.github.com/whatever.csv, we can make a reference to the dataset via that path as well. And also this concept of Azure Open Datasets. This is a library of machine learning ready data available in the public domain. And you might want to use this for your existing, to supplement your existing experiments, or potentially kick the tires on Azure Machine Learning using some of these interesting data sets. Okay, so we're going to create a data set from a local file. So if we're going to select that, now even though the automobile price data that we're going to be using is actually part of the sample set, so we don't actually need to bring that in for this demo, but just to show you what this process looks like, I have another data set based on Melbourne property prices, and so I might give my data set a name, so we're going to call it Melbourne property prices. You have the option to choose tabular or file when it comes to the dataset type. So if your data is already in a tabular format, it's in rows and columns and can be easily inferred, schema can be inferred, you want to leave it in tabular. Tabular allows for easy ingestion into a Spark or Pandas data frame for further manipulation. Alternatively, you could leave it as file. So we're going to leave it as tabular. When uploading this data set, we need to decide which data store that we want to put it in. And so I can leave it as the currently selected data store, which is the default associated with my Azure Machine Learning workspace. We have the option to switch that up if you want to put it into something else. Alternatively, we can create one on the fly during the dataset creation process. But for now, I'm just going to leave it as default. So next, we're going to browse to our actual data set. And so here is our machine learning property data. I'm going to click next. It's going to upload that. We're going to get a preview of what that data looks like, as well as some settings. And so how is this file delimited? How is it encoded? It all looks okay, but you can see here in row 1 that my row 1 actually needs to be promoted to my headers. And so I'm just going to change this option here to use headers from first file. That looks much better. So let's click next. Next, we have the schema. Azure Machine Learning has already inferred all the different data types of all the different columns within my data set. You can decide to drop some of these right here in the dataset creation process. I'm going to leave everything as is because it looks okay to me. So let's click next. And then last, we've just got the confirmation screen, but you can see at the bottom there we've got this ability to profile the data. And so profiling data, one, I need to align it with a particular resource within my set of compute resources. And what Azure Machine Learning will actually do will analyze that data set and produce statistics on each of the columns. And we can see we've got one pre-done here under Explore. So I've navigated to my data set under Explore. Here's the preview, first 1,000 rows. But if I click on Profile, I'll get all the statistics on all the different columns. And so we've got min, max, standard deviation. If I scroll down to land size, for instance, so this particular sample was of one suburb within Melbourne, and it was sold prices over the course of 10 years. But for this particular suburb, I can see that the vast majority of land is within the 50 to 355 square meters, a mark before the distribution drops steeply to the next bin. So this is quite useful for identifying columns with like a lot of missing values. Maybe you don't want to bring those through, or you've potentially got imbalances in your data, right? And how are we going to cater for that when we're building our pipeline? The last bit that I just want to show is that in addition, on the Consume tab, you have this ability to copy some code that's already been pre-written. And so if I have, navigate over to Notebooks, I can create a new notebook. So let's call this Melbourne Property Prices, and just paste that code and run that to get connected to my data in a data frame, ready for further manipulation, in order to get started as quickly as possible in terms of building my machine learning workflow. So let's collapse this sidebar just for a bit more real estate. I'm going to change this code to Markdown, so we'll just call that Melbourne Property Prices. Change this back to code and we'll paste that in. I'm just going to modify it slightly. So put that into a variable. Yep. And just get the first 5 rows. And you can see my notebook, it's automatically connected to my compute instance, and there's the sample of our data. So we're ready to keep going from there. Okay, so we're ready to start building out our pipeline. So I've navigated to the designer authoring experience. This is where we can do drag and drop machine learning. Now you can see at the top here, if you're new to AML Designer, there are a number of samples across different types, so binary classification, cross-validation, text classification, etc., which you can go in and see these pre-configured examples. But we're going to build one from scratch. So let's click the brand new. Okay, again, we'll collapse our sidebar for more real estate. So quick tour of the UI. On the left-hand side, we have our series of modules that are available for us to drag and drop into our canvas. So we can just grab any of those, drag and drop. They've got these kind of connectors, which we'll find out a little bit more about in a sec. Now, if you're ever unsure about what a particular module does, hovering over each of these will provide a brief description as well as a link, an anchor link to the Microsoft Docs page for that particular module, so you can get to understand what it does, the inputs and the outputs, and kind of the properties that we can use to configure that module. Within the asset library, so while we're on the modules pane, there is this datasets pane. So here we've got our user-generated datasets. We have our samples that are provided out of the box with Azure Machine Learning, as well as pre-trained modules, which we can also drag and drop into our canvas. Okay. Up at the top, here's our pipeline name, which we can change. So we'll just call that auto price training. And here's the settings card. So clicking on that will toggle the settings pane on the right-hand side. Our action buttons. And just underneath the pipeline name, we've got our kind of typical menu items, right? So autosave is on by default, which is great. Otherwise, save, undo, redo, cut, copy, and paste. Okay, so if we bring that settings pane back up, clicking settings at this level is the settings at the pipeline level of granularity. And so you can see here in the red, the first thing it's asking is to select a compute target. So this is a compute resource that's aligned to this pipeline so that when I hit that submit button, it will have something to run against. So we're going to pick the AML cluster. Now, in addition to the default compute target, we can add, parameterize our pipeline by adding key value pairs, but we won't need that for the demo. And we have these pipeline details, which, a name and a description, but we'll leave that as is. Now, if I drag in a module, so let's say convert word to vector, that settings pane will update to be based on where I've got my focus. At the moment, I'm focused on that module. I can see the properties that are unique to that module. And what's interesting down below, run settings. So if I click on that, you can see by default, it will use the default compute target aligned to the pipeline, but we can override that for any particular module. So if you have a module that is better geared towards a particular type of cluster, you can override that at a module by module level. Okay. All right, so I think we're good to go. Let's start off by dragging in our automobile price dataset. And if you're interested in the automobile price data, or any dataset for that matter, you can right click on those and click on visualize, and this will provide us a sample view of the data, as well as some statistics on each of the columns. So if I click on this, I can see here, Toyota in this instance that's the most amount of cars for that particular car brand. If I click on normalize losses, I can see, for a data set that's relatively small, we've only got 205 rows, but normalized losses is 41 missing values. And so we may want to just drop that completely, because I don't think that would be useful for our training data set. If we scroll on the right hand side, we've got a bunch of numeric values. Something else of note, like the range, the min max of each of these, is kind of, they vary wildly. So we may want to normalize some of those as part of one of our pre-processing steps. And other columns like bore, stroke, and horsepower, they also have missing values, not near as much as the normalized losses column. So I think they'll still be critical in helping us predict the selling price of a car, but I'm not going to drop those columns altogether. So I want to just clean up those missing value records. And then all the way on the right here, we have the price columns. That's ultimately the numeric value which we're trying to predict. Okay, so let's start to drag in some modules that will help us pre-process this data, and most of those are going to be contained under data transformation. So the first one that I'm going to select, if we scroll down, is called Select Columns in Dataset. If I hover over, you can see the connector tells me what the output of that module is, and it will allow me to connect it to the input of the next module. Now there's this warning symbol here, and that means if I click on that, I haven't fulfilled my requirements of this module. And what I mean by that is that I haven't set the properties. And so if I hit Edit Column, and in this case it's saying which columns do you want to select from the dataset before, and I could manually type those, but what would actually be a lot quicker is if we do this by name. And so if I flick over to this view, we'll click Add All, remove normalized losses, and click Save. So we've dropped that column that we didn't want, but I also want to clean up those bore, stroke, and horsepower, right? Because they had some missing columns. So rather than select columns, I'm going to use the clean module. So clean missing data. So columns to be clean is what we need to select. So let's edit, and I'm going to just type these in. So we've got bore, stroke, and horsepower. Now the reason why I can't select the name, why is that grayed out, is because we haven't run our pipeline yet. So if we had run our pipeline up to the point of the previous module, the dataset output would have been available for us to just simply select. But since that we haven't done that, we need to manually type it in. Now the min and max, I'm going to leave those threshold values as are, because that will just mean that every single time it hits that record, it's going to take an action. And the cleaning mode that I actually want to instigate is remove entire row. That's the one that I want to trigger. But you have the option to play around with those thresholds. Next up, I want to normalize my data. And so if I go to normalize data, I'm going to drag that in, and you can see that I've just searched for that module. And yeah, so you can see in clean missing data, this one actually has two outputs. One is of the transformation, which I can tell that by hovering over the connector, or the clean data set. So I'm going to drag the clean data set, which is always typically on the leftmost left outer connector, to thing. Now, if I made the mistake of selecting the other one, Azure Machine Learning will actually not let me connect those modules because they don't work together. So dataset to dataset. And in terms of normalized data, I'm going to choose the min-max transformation method. But you have a number of options in terms of what you want to pick there. And I'm just going to copy and paste because there was a whole bunch, a laundry list of values which we want to put into this transformation. So we'll just copy, paste, and there's all our columns. Okay, so we've dropped the normalized losses, we've cleaned the records where we had some missing data, and we've normalized the values of our other numeric columns. So now we're ready to split our data. So if I hit split, and the reason why I want to split is because I want to reserve a fraction for training and the other fraction for validation. So I'm just going to set this to 0.7 in terms of the split, and setting a random seed just makes sure that we kind of get consistent results if we run this pipeline again. Otherwise it might be randomized. So the next module that I want to drag in is the train model. Now, train model will require two things. One is the training data set, but two is the algorithm that we're going to use in order to train the model. And so the algorithm that I'm going to pick is, if we go to machine learning algorithms, you can see here that we have a whole category under regression. I'm going to choose in this instance linear regression, but you may have decided or test which of these algorithms is most effective. So we'll drag that in. Now the reason why it still has that warning symbol is because I haven't actually told it which column that I want to predict. So in this case, it is price. That should get rid of our warning symbol. Perfect. And we're nearly there. So the next one we want to drag in is score. So score model will use the trained model as well as that fraction of the data that we left behind for validation, and we'll use the trained model to predict values, and we'll be able to compare those against the actuals. But rather than just eyeballing that, we're going to bring in the last module, which is evaluate model, to evaluate our scored data set to give us an indication of the model's performance. Now we can clean this up. We've got this auto layout button that will make it nice and neat and tidy, and we're ready to go. And so we hit submit. This is to execute this particular pipeline as a run, and we can pick or create a new experiment. So I've got a automobile train experiment. All that an experiment is a collection of pipeline runs. And so as we're training, we want to kind of keep all those within the same experiment, the same collection. But if you're training on something else, you've got a different hypothesis and you want to have that in a separate grouping, you would create a new experiment. Now I've already pre-run this to save us some time. So if we head on over back and check out this pipeline, see the exact same set of modules, and it's already cached your results because I've pre-run this. Now if I right click on score model, I can visualize the scored data set. I'll see that 30% of data that we left over. So here we've got, Subaru, a fuel type gas with a whole bunch of different characteristics. And if we scroll all the way to the right, we can see the actual price of $9,233 and the scored label, so the predicted price of $8,075 based on this particular model. Now we could eyeball the differences here, but if I go down to evaluate model and right click on that, I can see some statistics specifically about the performance of this model. So the mean absolute error, the coefficient of determination, etc. Now, if I like this model, I think this is, it's a really good model. I want to now promote this to an inference pipeline so that we can ultimately deploy this as an endpoint. And so up at the top here, we've got this new action button where it says create inference pipeline. So I'm going to create a real-time inference pipeline, which will promote our training pipeline to an inference pipeline. You'll see some of our modules have been kind of wrapped up. And we've got this web service input and output that are topping and tailing our pipeline. So that will allow a developer to call this, via a HTTP endpoint, for instance. Now, there are a couple of just minor changes I want to make before we deploy this to an actual endpoint. First off, the automobile raw price data, we don't need that anymore because we've trained our model. So what I'm going to replace it within is the, if we go to data input output, there is this option to drag in enter data manually, just to test as we're kind of testing our inference pipeline. And so at the moment it is set to CSV. I'm going to copy some CSV data from my OneNote, paste that in there. So that's 3 different cars, but without the price data. So this is data that the model has not seen before. That looks good. The other change I want to make is select columns in Dataset. So while we still want to drop the normalized losses, because that's the reason why we drag this module in, we no longer need to think about price because we won't be getting price as part of data that we haven't seen before. Evaluate model, we don't need that anymore because this is a trained model and we'll be using this to infer, so we can get rid of that module. And we're pretty much good to go. The only thing that we may want to change is that at the moment, score module is passing everything as is to the web service output. And so I'm going to actually delete this connector and interject a Python script module to pass that data before we provide it to the web service output. Now remember, Azure Machine Learning Designer is a visual first experience, but not visual only. And so we still have the option of executing Python or R. And this is going to be fairly simple Python code, so I'm just going to delete all that and copy this code. And all that code is doing here is we're importing the pandas library. As we get the data frame as an input, we just want to get the scored labels, just that column. We're going to rename that to predicted underscore price and then pass that to our web service output. So we would submit that Once that's submitted, and again, we've got one that's pre-run, so let's have a look. So here it is pre-run, we've got all the results cached. If I right-click on Execute Python Script, you can see rather than the entire score data set, we're just getting the predicted values. And so that's what's getting passed to our web service output. So there's the 3 prices for the 3 different rows. And if we're happy, we can now deploy that so that it can be served as a HTTP endpoint that we can pass on to our developers. And so we need to select an inference cluster, an inference type of compute, and there's our AKS cluster. And if we head on over to endpoints, I can show you what that looks like. And so here we have an existing endpoint. Now I can test this immediately within the UI. For instance, we can test it with the current values, which produces a value of $15,000. If I change this Alfa Romeo to Toyota, it will change it to $12,688. Now, if we want to test this in a notebook, we have the ability to copy and paste the endpoint and key. And again, there is some sample code in C#, Python, and R to get us started more quickly. Now, I've already pre-created a notebook, so I'll just bring that up in a new tab. And we'll collapse all this to give us some real estate. And we will need our endpoint and our key. And so I'll just run this widgets module. Okay. So endpoint and key. So let's just copy that from the consume tab. Paste the endpoint. Paste the key. And in terms of the code, it's really straightforward. So we're importing the request and JSON Python libraries. We're constructing our JSON payload that contains all the characteristics of the car that we want to predict without the actual price, of course. And then we've got the HTTP request, pass the results. I'll just clear the output of the previous run, pass the results, and then produce that in some formatted text. So if we run that, we can see for this particular car, it predicted the price to be $12,689. If I change it from from Toyota to BMW, we'll get a different price, and so just the make has increased that to $20,000, but for the same characteristics of the car. Okay, and that is essentially Azure Machine Learning. And so that is AML Designer, and we also got a bit of a view into the notebooks. And as I mentioned, you can see on this screen, this really kind of simplifies the build, test, and deploy process of building out your machine learning models. Great for ML novices that are looking to expedite their learning, or for those that do understand machine learning, but maybe not necessarily super proficient in Python coding. Or on the other end of the spectrum, you are an ML expert, and you just don't want to crunch code every single time you want to test one of your experiments. And so Machine Learning Designer is a good way to rapidly prototype. If you'd like to get started, head on over to aka.ms/AMLfree, where you can get set up with your free Azure account with that kind of starting set of credits. And this particular exercise is actually available on Microsoft Learn. So if you head on to Microsoft Learn, there is a learning path that runs through this exact same exercise with the automobile price data. And with that, I'll say thank you.